Thank you. Good morning. Yes, so this presentation, 55 new features in JDK 9, originally was intended to be an hour long, and I have 50 minutes, so it'll be a little bit of a challenge to get it into the 50 minutes I've got. Of course, a couple of people have asked me to do it in 45 minutes in the past, and I've just about managed to do that. So I think we'll be OK if we keep moving at a reasonable pace. This was really a sort of follow-on to the appropriately named 55 new features in JDK 8, and even before that I did a session called 55 new features in JDK 7. I'm already planning the next one, which is going to be called 5 new features in JDK 10. Now, what I've done is divide this up into a number of sections so we can talk about the different groups of features. And we'll start with the big things in JDK 9. Obviously, the biggest of those is modularity, Project Jigsaw. And I don't want to spend too long on this because I could clearly spend the entire session talking just about modularity, how it's been implemented, and what it does. But there are a few things that we need to understand in terms of what it really means for developers, what it really means when you're deploying your applications. So the first of those is the fact that now we don't have an rt.jar file. In JDK 8, rt.jar had about 4,500 classes in it, which made it really rather monolithic. In JDK 9, we now have 97 modules that make up the JDK. And those are sort of broken up into different groups. There are 28 of those which are part of the Java SE standard, the standard that's defined through the JSR 379. There's also some modules there that are for Java FX. There are 59 that are specific to the JDK itself. So that's some of the compiler tools, monitoring, things like that. And then there are 2 which are Oracle specific as well. The other key thing about modularity is the idea that a lot of the internal APIs, which are the APIs that you're not supposed to use, and are there to make the public APIs work, are now encapsulated. And the most famous or infamous of those is Sun Microsystems. So quick show of hands, who here has used Sun Microsystems? Okay, a few people. Okay, who here has used a third-party library or framework in their application? Yes. So you've probably used Sun Microsystems, you just don't know it. The important thing about that is that the developers of the modularity system have provided you with ways to get around this encapsulation. That's so that backwards compatibility isn't completely broken. So if you do actually need to get access to things like Sun Microsystems, then there are ways that you can specify things on the command line that will allow you to do that. So there is the wonderfully named big kill switch, which allows you illegal access. There's also a couple of smaller ones. There's add exports, which will allow you to import the internal APIs that you need. And there's add opens, which allows you reflective access to the APIs that you want that have been encapsulated. The other thing around modularity is actually taking the source code and modularizing that, breaking it up into the same set of modules that we've got in the runtime in order to make it easier to maintain, easier to understand how the layout and so on works. Migrating applications to the module system. This is quite important. So the first thing that you need to understand is that for most applications start off simply by leaving everything exactly the way that it was in JDK 8. Leave everything on the class path. That will become part of the unnamed module. And then all of the packages that you have there will be exported to all of the modules on the module path. Everything on the module path will be accessible to the classes you have on the class path, which are part of the unnamed module. So this gives you a simple way of at least starting your application. Obviously, there may be a couple of things you need to change, because if you are using internal APIs, you'll need some extra command line options. But if it's a simple application that only uses the standard APIs, then leaving everything on the class path should just work. Then, if you want to, you can migrate to the module system in a gradual way. You can use the idea of automatic modules, which is where you take a jar file that hasn't been converted to a module, move it from the class path onto the module path, and then the module system will treat it as if it is a module, even though it doesn't have the module info.class file. By default, its name will be the same name as the jar file. It will export all its public packages, and it will depend on all the other modules on the module path. So again, it gives you a way of migrating from the class path to the module path in a simple way. And then as you recompile code, you can actually add the module info.java file, compile it, and make it into a proper module in terms of the module system. I mentioned the big kill switch. This is the idea of turning off encapsulation completely from the point of view of reflection. So what you can do is you can specify the, again, wonderfully named illegal access. And there are 4 options that are available with that. The default, currently, is permit. And what that will do is it will allow you to gain access to these internal APIs. Every time you use, well, the first time you use one of these APIs, you will get a warning message printed on the standard output or standard error. If you want more information, you can dial that up a bit. You can go to warnings and use the warn version of that. That will then give you a warning message every time you use an internal API. If you want even more information, you can go to debug, and that will give you a warning message every time you use an internal API. Plus, it will give you a stack trace so that you can see how you got to the point of using that particular class or method. The last option is deny, and that's what is intended to be the default in the future. Not sure when that will become the default, but that's when it turns off the idea of access to the encapsulated APIs. Again, if you want to use the add exports and add opens, add exports gives you a fair amount of flexibility. You can say, in the case of the example here, we've got the java.management module, and we want access to the Sun JMX remote internal package, but only to my test. If we want all of the unnamed module to have access to that, then we can specify Java management module, Sun management, and have access to all of the modules, all of the things on the class path as well. For reflective access, it's very similar. So you can add opens, java.base module, and we can then say java.util is accessible through reflection to all of the unnamed module. Closely related to the module system is the idea of jlink. And this is the idea that you can create a runtime that is specific to your application. It's really sort of moving away from having a centralized JDK that all your Java applications make use of to the idea of having a JDK that is shipped with the application, and you can then use that in whatever environment you want. It's really kind of very suitable to the idea of containers and using things like Docker, because you can build a runtime that's specific to the microservice that you want, and then put it in your container and ship it as part of that. The way that jlink works is to take a set of command line options, a particular module that you want to build a runtime for, and then it will create a directory structure which looks the same as the JDK directory structure, and has the runtime for your application, but only with the modules that you need for that application. In this very simple example here, what we're doing is we're saying, OK, create a runtime that only has java.base in it. So in that case, it's actually no use to you because there's no application to run. But what you get is a directory structure that has the bin directory, conf directory, jmods directory, lib directory, and so on. If you run the Java command within the runtime which you've just built, and you go into the bin directory and run that, and you specify the list modules command line option, in this case what you'll see is java.base. So that's the only module there. If we go a little bit further and we say, OK, let's take a real-world application, we can do the same thing, specify where the modules are coming from, specify that we have a module that contains a main, static void main entry point, and again, build it into my image. If we then run the list modules on Java, what we'll see is we've got java.base, we've got Java logging, SQL, XML, and then we've got some application modules in the form of app, Zoop, and Zeta. If you look at that, you'll see that there are also some numbers there. And then you might think, ooh, look, we've got versioning. Don't get excited. It's only for information purposes. The module system does not support the idea of versioning so that you can have different versions of the same module. Moving on from the idea of modules, other things that we have in terms of APIs. One of these is the idea of adding factory methods to collections. So the collections API has been around for a long time, and we have three kind of key interfaces. We've got list, we've got set, and we've got map. The problem is that up until now, it's been rather verbose in terms of creating a small collection of fixed values. As an example, if I want to create a set with 3 values in, I need to do something like this. So I first of all have to instantiate a hash set. Then I have to call add 3 times to add A, B, and C. Because I want the collection to be unmodifiable, what I get by default is a modifiable set, so I then have to use the static method on the collections utility class and then reassign set back to itself as an unmodifiable collection. What these new factory methods does is add a large number of overloaded methods to these interfaces. JDK 8 introduced the idea of default and static methods in interfaces, so we could have multiple inheritance of behavior in Java. And by doing that, it simplifies where these methods need to be added. Add them at the top level, so list, set, and map, rather than having to add them into each concrete implementation of those. So now we can simply say that we want a method call which will take 0 to 10 elements, and so there are 11 overloaded methods that allow you to specify whichever number of elements you want to create the collection of. And then there's a last one which is designed for if you need more than 10 elements, then you've got a varargs way of doing things. The reason for having so many overloaded methods is performance, because the varargs way of doing things requires you to create an array, you have to populate the array, you have to pass that array, then you have to remove the elements from the array, and you've got all the overhead of garbage collection and so on. This really simplifies things down, so now we have one line of code. It's up there, isn't it? Yes. One line of code which simply says, OK, we want to create a set of type string, and then we just call the method set.of and pass in 3 arguments, A, B, C. So it's a nice sort of way of cleaning up the coding that you need to create a simple collection. There are some enhancements around the Streams API. Streams were introduced in JDK 8. Very nice. Lots of people like it. It's very useful. And what they've done is add just a few new methods there. Not a lot of things, but a couple. So the key ones here are drop while and take while. The idea here is that these are like skip and limit that we already have. Skip allows us to say, OK, we want to skip the first n elements of the input stream and then pass the rest to the output stream. Limit is the opposite of that, where we specify we only want the first n elements of the input stream and then ignore the rest of it. That requires us to know exactly how many elements we want to either skip or limit our stream to. So it's an integer. Drop while and take while use a predicate. So we now can specify a condition. As long as that condition is true, then we will either drop elements from the input stream or take elements from the input stream. Once the predicate is evaluated to being false, then it flips the state. So if we're doing drop while, we will start taking elements from the input stream. If we're doing take while, we will start taking elements from the input stream. So it allows us to specify a condition rather than a fixed value. The iterate method has iterate method has been updated, so there's now a new version of that, which allows you to create an iterate which looks like the traditional for loop. So we're used to the idea of, for int I equals 0, I less than 10, I plus plus. So there's now a version of the iterate method that takes 3 parameters. The first is the initial condition, so what value you want to start with. Second is predicate, which says when you want to terminate the iteration. And the third is a function which says what happens each time you go through the iteration. The files.lines method has been modified so it will work with a parallel stream. If you tried to use the files.lines before in JDK 8 and you passed it into a parallel stream, you'd actually get very bad performance, worse than if you used a sequential stream. Problem is that obviously you're reading elements from the file sequentially and then trying to distribute them amongst a number of threads. The overhead of starting up all the threads, the fork join framework, and so on, is more than the benefit you get from trying to do things in parallel. Now what happens is if you pass the stream from files.lines to a parallel stream, the system will recognize that and will say, OK, take the file that you're trying to read from and map it into memory. Once it's mapped into memory, it can be divided up into a number of regions, and each thread in the fork join pool can have its own pointer. It can then read independently, and you can actually get better performance in terms of parallelism. So you will see an increase in performance based on how many cores you have and so on. So it's a really useful thing in terms of how that works. Optional has a couple of new methods. One of those is the idea of being able to produce a stream from an optional. So you get a stream of either 0 or 1 element, depending on whether you've got a null pointer or a valid reference. Multi-release jar files have been introduced. So the idea here is that if you want to provide code in a jar file and deliver it in such a way that it can work with different versions of the JDK, depending on what features are available, then the jar file will now be able to support that. Now, at the moment, you might think, well, that's great, because we have JDK 9. I can create a multi-release jar file that has 1 release in it. However, there is actually a way of doing it so that you have 2 releases, because the jar file is backwardly compatible, which means that you can run a multi-release jar file on JDK 8. What JDK 8 will do is it will ignore the multi-release part of the jar file and simply use the files it finds at the top level of the jar file. If you run it on JDK 9, because JDK 9 understands the multi-release jar file, it will look in the appropriate subsection of the jar file, which means you can include a JDK 9 version and a JDK 8 version and have those run differently depending on which JDK you're running on. Once we get to JDK 10, next month, then you'll be able to have multi-release jar files that will support 9 and 10 as well. Various things were sort of modified to support that, things like Java C, Java P, and so on. The JShell, or the REPL, the read eval print loop. This is something that a lot of languages, a lot of runtime environments have had for quite a while. And what it allows you to do is to have a simple way of doing prototyping. Quite often, you find that there's a situation where you've got a little bit of code that you want to figure out, well, what does that actually do? And if I change things, how does it modify what the results are? Rather than having to do that in your large application and then trying to isolate that out or writing a test situation for it, you can just fire up JShell, type in a few lines of code, see what the different things evaluate to, and then work out what you need to do in your project. I must say, when I first saw this, I thought, I probably won't use it much myself. But I have found there have been several instances since it came out where I thought, oh, yes, that would be really useful, and just used it to experiment with a bit of code. It's got all the usual sort of features you'd expect. It has history. It has the online documentation accessible. You can save all of the work you've done into a file, so you can import that into a IDE if you want. So all of the typical kind of things that you would need to make it usable and as efficient as possible. Concurrency updates. Concurrency is a big thing in Java. We've had this right from the very beginning. We've had the idea of the concurrency utilities in JDK 5. We've got fork join framework in JDK 7. We got the parallel streams in JDK 8. In JDK 9, we're taking that a little bit further. So one of the things is the idea of a reactive streams framework. Reactive streams have become quite popular recently because it's the idea of using threads in an asynchronous way. So we don't have to block threads, and we can actually make more efficient use of the threads to get more work done. What JDK 9 includes is this idea of a reactive streams publish-subscribe framework. And how this works is that if you think of the situation where you have a web browser. Web browser is sending requests to a server. The problem is that the web browser, or the application code running on the web browser, doesn't know how many requests it can send to the server before the server's potentially going to block because it gets overloaded. So the idea of the reactive streams is that you can use this publish-subscribe framework to solve that problem. The client, the web browser, can become a publisher. So it publishes messages or requests. The server becomes a subscriber, and it subscribes to a certain number of messages. The way that then works is that the browser, when it says it's going to set up as a publisher, the server says, OK, I'm setting up as a subscribe to that. I will subscribe to 4 messages. The client can then send up to 4 messages, safe in the knowledge that that won't block. It then knows that if it needs to send another message, it has to make a decision about, does it send it to the same server with the potential for it to block, or does it go to a different server? Does it wait? Does it make a decision about what it needs to do? So the idea is to have this simple publish-subscribe idea. So you've got publisher as an interface. All of this is interfaces mostly. So you really have to write most of the code for this. You've got the publisher interface. You've got the subscriber interface. A processor, which is both a publisher and a subscriber, so that you can chain these things together. And then you've got the idea of a subscription to link them together. And obviously, as the server processes things, it can change the subscription to say, yep, now I can take more messages from the publisher and have that updated continuously. Another area where JDK 9 makes some updates is in the completable future class. So completable future was introduced in JDK 8 as, again, an asynchronous extension to the existing idea of a future. In JDK 5, we got the idea of changing from using just a runnable to using a callable. So you could use a callable, which would enable you to get a result back from a separate thread of execution. The way that worked is that the callable would give you a future. Future had a single method get, and when you wanted the result from that thread, you would call the get on the future. Problem was that that would block if the result wasn't ready. So if you didn't have the result, you just sit there waiting for the result to become ready. Completable future is asynchronous. So what you do there is you register a callback method so that you don't have to sit there waiting for the result to be made available. You simply say, when the result is available, call this particular method, and something can happen. So that's very good. It all works very nicely. And in JDK 9, there have been a few updates to that. Certainly in the area of things like delays and timeouts, so that you can specify what you want in that respect. If you don't want to continually wait for a result, then you can do that. There's also better support for subclassing, because people often find that they want to subclass completable future for specific things. And then there are a new set of static utility methods. And this is where kind of life gets interesting, because there's this idea of a completion stage in the completable future, where you can effectively have a sequence of things that happen in that callback. So you can provide a completion stage. And so 2 of the static utility methods are a minimal completion stage and failed stage. So I'm going to read you the Java doc from minimal completion stage, because this is quite interesting. So a minimal completion stage returns a new completion stage that is completed normally with the same value as this completable future when it completes normally and cannot be independently completed or otherwise used in ways not defined by the methods of interface completion stage. If this completable future completes exceptionally, then the returned completion stage completes exceptionally with a completion exception with this exception as cause. That is all English. I have no idea what it means. Somebody at some point is going to explain to me what a minimal completion stage actually does. Anyway, so there's a couple more which I really like the names of. There's a new incomplete future and a failed future. Enhanced deprecation. Now, we've had deprecation for a long time in Java, right from 1.1. And the idea there is that methods, classes, interfaces, and so on could all be marked as deprecated if the idea was at some point in the future to have those things removed, or there was an alternative that was a better thing to use instead. We've had the deprecated Java doc tag from 1.1 in JDK 5 with the introduction of annotations. We got the deprecated annotation. And now in JDK 9, that's kind of being extended a bit to give you more information. 2 things that you get in terms of methods. One is for removal. That returns a Boolean, which will indicate if it's true, then this element is scheduled for removal in the next release of the JDK. If it returns false, then it may still be removed at some point in the future, but it won't be in the next release. There's also a string that you can get, which is since, and that will give you information about which release of the JDK this particular element was deprecated. They haven't gone back and retrofitted all of that, so it only starts with JDK 9. But maybe at some point in the future, somebody will do some like historical research and actually go back and fill in all the versions of that. A number of elements have had the deprecated tag added to them in JDK 9, so there's things like the applets API, other things like that. But there's also, interestingly, 2 elements which have had the deprecated tag removed. So if you look at the java.awt component, show and hide methods, they used to be deprecated, now they're not. Which sort of brought up the discussion that I had with some of my colleagues about how do you declare that? Is it de-deprecated or is it just precated? But anyway, and then there's a tool called JDepreScan, which is very useful because that allows you to look at your code and actually identify any places where you have used deprecated elements, and therefore you can go back and make changes if you want to. Milling Project Coin. This is changes to the language itself. And so in JDK 7, we had Project Coin, which was small changes to the language. Things like strings in switch statements, the try with resources block, and so on. JDK 9 has 5 different things which are changes at the language syntax level. First of those is that a single underscore is no longer valid as an identifier. It's now a reserved word in Java. So hands up, anybody who's used a single underscore as a variable name. All right, OK, 1 or 2 people. Great. Well, you're safe because you can still use 2 or more underscores as a variable name, because I did check. The idea behind this is that in, I think it's JDK 11 this is scheduled for, that a single underscore will be used in a Lambda expression, potentially. So if you have a Lambda expression where you've got a parameter that's not used in the body of the Lambda expression, you'll be able to use a single underscore to sort of hide the parameter and make it easier to read. Private methods in interfaces. Again, as I mentioned, with the introduction of static methods and default methods in interfaces, we now have behavior. Private methods means that if you've got several static methods or default methods, all of which share a common piece of code, you can now extract that out into one method and have it private within the interface. And then if you need to update it, rather than having to update it in several places and potentially make mistakes, you can just do it in one place and make your code look easier to read. Effectively final variables in try with resource blocks. This was one of those kind of quirks that the try with resources block introduced, was the fact that you can have a variable from outside the try block, which you want to use inside it. It's already declared. But you still had to reassign it to a new variable name in order for the try with resources block to work. Now, in JDK 9, you can simply put that in the brackets of the try block. You don't have to assign it to a new variable, and that will work just as well, as long as it's effectively final. Safe varargs annotation on private instance methods. Again, this is really sort of a tidying up feature, because the safe varargs annotation, which is used when you've got a combination of generics and variable arguments that the compiler gives you a warning message about, which you can't get rid of, because there's nothing you can do to change that, then you can use that currently on constructors, on final methods, and static methods. All of those can't be overridden. So, overridden. So in the case of private methods, it just makes sense to extend that to the same thing. Diamond operator with anonymous classes. Diamond operator was the simplification and the improvement of type inference that we had, so that if you have like a list of type string and you assign it to an array list, you don't have to specify it's array list of type string again, because the compiler will know that the array list has to be of type string. What you couldn't do is use the diamond operator if you had an anonymous class. And the reason for that was that there were situations where the type inference that the compiler would generate was what's called a non-denotable type. It was one that the compiler could understand, but it was a type that couldn't be represented in terms of the class file structure, and one that the virtual machine would understand. Now, so long as the type that's inferred is a denotable type, so it can be represented, then you can use the diamond operator. So essentially, you just try it and see whether the compiler likes it or not. Standards. There are lots of standards that get used in the JDK, and all of these, or most of these, need to be updated to the most relevant versions. So the first of those was Unicode, and there were 2 new versions of Unicode between JDK 8 and JDK 9. And I actually did a little bit of research on this, and I found that Unicode 7 introduced 2,834 new characters, and Unicode 8 introduced 7,716 new characters. So nearly over 10,000 characters. And you think to yourself, where did they find 10,000 characters? Anybody want to guess? Emojis, yes. So emojis are the thing that, like the hieroglyphics of the modern age. Also, interestingly, there were some other things that got included there, which, again, slightly bizarre thing to include, but lowercase Cherokee, the Native American language, is now included in, I think, Unicode 8, yes. Standards for things like cryptography stores, so the public key cryptography store 12 is now used by default rather than the Java key store. The HTML or Java docs have been upgraded to HTML5, so we get some nicer looking documentation. And the hash algorithms used in SHA3 have been upgraded to keep us ahead of the hackers. Smaller features that have changed in terms of standards, property files now support UTF-8. So you think to yourself, great, what does that mean to me? Well, it means that you can now use Unicode, which means that in your property files, you can now use emojis. Or you can use lowercase Cherokee. Second thing, DRBG-based secure random implementation. So I looked this up as well, and apparently DRBG is a deterministic random bit generator. Now, I don't know about you, but I thought that random meant non-deterministic, not deterministic. But anyway, I haven't gone into that in any more detail. And the XML catalog API has been upgraded to the latest version from Oasis, which is version 1.1. That's used in the Java API for XML parsing. Inside the JVM, what things have changed at that level? Well, the first is that the default collector for a server class machine, and if you ask Oracle what a server class machine is, it is one that has 2 or more cores, 2 or more gigabytes of memory, and is not running Windows. I don't make this up. Anyway, so G1 is now the collector by default for server class machines. Makes sense because it's been around for quite a while. It's a fairly mature development. There have been various things that have changed recently in some of the updates to, again, improve efficiency of that. It is designed as a low-pause collector, but I work for Azul, so I'm going to spend 15 seconds in terms of doing some marketing and say that in the case of G1, as with all other collectors except for Zing, you will fall back to a full compacting collection, which is where you get these big pauses. If you want really good low pause, low latency collector, then have a look at Zing because it doesn't have a fallback of a compacting collection. End of marketing message. Better string performance. 3 things have been changed around strings in the JVM in JDK 9. The first of those is compact strings. What this does is it looks at the fact that internally in the JVM, strings used to be stored all using 16-bit encoding for each character. But certainly if you're in Western Europe, the US, Canada, a lot of places like that, we all use 8-bit character encodings. ISO 88591, 2, and so on. And the problem with that is obviously you're wasting a lot of space. If you've got a lot of strings, half of the space you're using is not really necessary because you're using an 8-bit encoding. Now, in JDK 9, if the encoding that's being used is 8-bit, there's a flag at the beginning of the string internally which is set to show that it's using 8-bit encoding. If it's not set, then it'll be 16-bit encoding. So that effectively almost halves the amount of space you need. I say almost because, of course, you need the flag, so that's a little bit of extra space. The other thing is that the strings that are being used by the JVM can now be stored in the class data sharing archive. This is the idea of having an area of memory on your machine which is shared amongst all the JVMs that are running. So if you've got multiple JVMs running, up until now, you've been able to use it to store the classes of the JDK itself. Now, it will also store strings so that if you've got several JVMs running on the same set of strings, they don't each have to have their own copy in memory, and they can share it. Third thing around string performance is the idea of improving the way string concatenation works. What this does is it says, instead of encoding the way that string concatenation works into the bytecodes generated by the compiler, use an invoke dynamic bytecode. And this effectively says, leave it to the JVM to decide at runtime what is the best way to concatenate these strings. Then, depending on what the JVM wants to do, if somebody comes up with a new, improved way of concatenating strings, then that can be used without having to recompile the code that you've got. The graphics renderer. This is a small change that was made because in OpenJDK, there was an open source graphics renderer called Pisces. Because that didn't have as good performance as people wanted, the JDK that was produced by Oracle had a closed source version that they used to replace that, and that was called Ductus. What's happened now is the Pisces open source version has been replaced with a new one called Marlin, and that has pretty much the same performance as you get with the closed source one. So it's really just a shift to using a better performing open source graphics renderer. A few smaller features, improved contended locking. This is very low level in terms of the JVM itself, but it's a way of having the JVM do different things in terms of the reordering of the fields that it uses, the cache line alignment, and just giving you slightly better performance when you've got contended locks from multiple threads. Second thing is the idea of using the CPU instructions that are available in pretty much all modern processors to be able to do some of the cryptographic side of things. So rather than having to do it in software, you push it down into the chip, let the hardware do it. And depending on which benchmark you look at, it can give you anything up to 150 times better performance on those tests. So that's a good thing if you're doing a lot of cryptographic stuff. The last thing of that is that the Java FX side of things is now using the latest version of GStreamer. Don't have to do anything different. That just uses the media class, and you'll get that by default. A few smaller features. Segmented code cache is to do with the way that the JIT compiler works. And what's happening here is dividing up the code that's generated in 3 different areas. So you've got non-method code, you've got profiled code, and non-profiled code. Again, the reasoning behind this is really about looking more into the future so that different optimizations can be applied to different segments of the code based on where they are in terms of the actual cache. Big thing that's changed is the idea of the way that logging happens for the JVM. So there's now a unified logging framework that's used across the whole JVM. It used to be that each subsystem used its own way of doing logging. Now there's a single logging framework in the JVM, and all the different subsystems can make use of that. Obviously, one of the subsystems that's going to use that is the garbage collector. What this means for people who are using garbage collection logging is that you may have to make changes to, well, certainly to the command line options you use, but also you may need to look carefully if you're parsing GC logs to see whether the format of the messages has changed from what you're expecting. A few specialized features. Couldn't think of a particularly good thing to put there, so I used a minion. Spin weight hints. This is an interesting thing for us at Azul because it was a change that we proposed as a JEP, a JDK enhancement proposal. And we are the first company outside of Oracle to propose a JEP and actually have it accepted into the JDK. I will say that it was quite a lot of work in terms of what we had to do, but that's a good thing, you see, because all we did was add one method to the thread class. But if you're going to add one method to one of the most fundamental classes in Java, you want to expect people to be taking notice of it and making sure that you're not breaking anything. So what this does is it adds a method called onSpinWait, and the idea behind this is to improve performance or lower power consumption if you have a situation where you've got lots of contended locking going on and you think that you may be able to acquire the lock fairly quickly, so you would typically spin the processor. Rather than doing a context switch, you just spin the processor with the idea that that lock will become available very quickly. Now, if you set the onSpinWait hints, then the processor, rather than spinning, it will use the pause instruction of the x86 instruction set. And again, that's like slight reduction in power consumption. And we have found with things like the disruptor from LMAX that we get better performance on that. Variable handles. These are looking at how to replace the functionality of Sun Microsystems, which, because it needs to be encapsulated, there needs to be public APIs that replace the functionality of that. What variable handles do is give you some of that functionality that you would get from Sun Misk Unsafe, specifically around the idea of fencing operations and atomic operations. Now, atomic operations you can do already using the atomic class, which is part of the concurrency utilities. That's great, except that it has the overhead that you need to create a new instance of that class. So you've got the object creation, allocation, then you've got the garbage collection that goes on behind it. So to get around that, people use Sun Misk Unsafe where they can use a primitive value and they can actually do atomic operations on that directly. Same thing with fencing is there are situations where the JVM is allowed to reorder instructions to optimize efficiency. And there may be cases where people don't want the loads or the saves to be reordered by the JVM. So you put a fence around it to say, don't change things in this section of code. The variable handles, again, allows you to do that. So there's ways of setting up a fence. There's ways of doing things like compare and set, compare and exchange, all those types of atomic operations. Ahead of time compilation. This is an experimental feature that's been included in JDK 9. And often when you talk to people about Java, they think, well, it gets compiled to bytecodes, and bytecodes get interpreted, so that's slow. But wouldn't it be just easier if I could compile my Java code into native instructions and then it would just run really fast? And the answer is, well, yes, it runs faster than bytecodes. But because the JIT compiler can optimize things more because it knows exactly what's happening in terms of your application, so there's both the ability to do better method inlining because it knows which methods are there. It also can do more speculative optimizations. But the idea of ahead-of-time compilation is to allow you to compile your Java code into native instructions, but then you lose the cross-platform functionality. What that does is it means that when you start your application, it will run a lot faster because you're using native code rather than interpreted bytecodes. Then, as the application continues to run, it can be profiled, and then the code can be recompiled using the C2 JIT compiler and get better optimizations. So it's a way of eliminating some of the warm-up phase that you get with a traditional JVM. As I said, this is an experimental feature. It's more kind of setting the groundwork for things that are planned in the future around Project Metropolis, which is using the Graal compiler and rewriting a large part of the JVM in Java. A few smaller features. Compiler control. This is a directive file that can be used to send information or send control to the JIT compiler. It's not Java-C. There's also some updates to the process API. We've had the process class before. Now we have a process handle. Process handle can give you information about running processes in more detail. So you get the arguments, start time, CPU usage, and things like that. And you've got better control over native processes. You can terminate processes on so long as you still have the access control for that. Housekeeping. A lot of housekeeping in JDK 9. So first thing was we get a new version string format. And this seems to be the idea that every release of Java has a new version string format, or at least that's the way it appears. This has always been a problem because engineering meets marketing and the two collide and it doesn't really work. So if you look at the fact that you download Java SE8 update 131 and then you do Java minus version, what you get is JDK 1.8.0_131, which doesn't really make a whole lot of sense. So in JDK 9, the idea was to change that into a more semantic versioning numbering scheme, which is major, minor, security, and patch. OK, 4 numbers separated by periods. Great. That'll be wonderful. No. Don't like that. We're going to change it again. So then we came up with the idea that because we're switching to a 6-month release cycle, why don't we use a date? So we'll have JDK year month. So the next release would be JDK 18.3, then it would be 18.9, and so on. No, don't like that. Don't want that, because people really didn't like that idea. So now we have another new version string format, which is very much like the one that we have for JDK 9, but subtly different. So now we have feature interim update patch. So we're going back to the idea of JDK 10, JDK 11, and so on. And essentially, you'll get possibly things like JDK 10.0.1.1. My personal thing that I don't like about this is that the interim number, if you read the JEP there, the interim number will always be 0. Well, great. If it's always 0, why is it there? Anyway, I move on. JRE, JDK file structure has changed. I kind of briefly mentioned this when we talked about jlink. It used to be that the JDK and the JRE were sort of considered two separate things. So you had a JRE subdirectory within the JDK. You had two bin directories, one for the JDK, one for the JRE, both of which had Java in it. And so you got two Java executables for the price of one. Now that's been flattened out, so we now have one bin directory, a conf directory for all the things that need to be that potentially could be changed in terms of configuration, lib directory, jmods directory. JRE directory's gone away, tools.jar's gone away, rt.jar's gone away. Small little features, searchable API documentation. Can you believe that it's taken us over 20 years to get a search box on the Java docs? But anyway, that's my favorite feature in JDK 9. Annotations pipeline has been updated. This is just to deal with some repeating annotations, Lambda annotations, and so on. And the parser API for Nashorn has been updated in various ways, and there's also support for the ECMA script 5.1 specification. General cleanup, SHA1 certificates are mostly going away. There's a few situations where they still need to be used, but the idea is to get rid of them eventually. The applet API has been deprecated. WebStart and so on is all deprecated as well. So Tumbling Duke will finally tumble off into the sunset. Other things removed from JDK 9, 6 methods have actually been removed. The add and remove action listener from pack 200, unpack 200, and log manager. You think, what did these 6 APIs do that was so bad that they're the first APIs in the history of Java to get removed? And it's simply because of the way that modularity had to divide up the runtime, and it just made it easier by getting rid of those. One class was removed, dialog callback handler, part of the Java authentication and authorization service. The ability to run different JREs from the command line, that's gone as well. So --version :release doesn't work. -version does still work, so you can see what version you're using. All the demos, all the sample code, that's gone from JDK 9 because they were never really maintained or updated. Same thing with the JVM TI hprof agent, only ever intended as a demo. The JHAT tool was introduced in JDK 6 as an experimental idea. That's never been updated, so that's gone as well. A range of garbage collection options have disappeared. So these were deprecated in JDK 8, and now they won't be supported. So if you try running your JVM with these options, it just won't work. Most of it's around incremental concurrent mark sweep, but there's also things like if you're using parallel new and serial old, why would you do that? So it's no longer supported. So that is 55 new features in 47 minutes. Pretty good. Right, summary then. So JDK 9, the big new feature is obviously modularity. Numerous areas of the JDK itself are affected by this. The idea of jlink to be able to build runtimes, the whole modules, the encapsulation of internal APIs, and so on. There are a number of smaller developer features. There's the new APIs that have been added to streams. There's reactive API, changes to various other different bits and pieces, JShell, the REPL, and lots of smaller features around standards and performance and JVM and so on. I would suggest, if you're thinking of deploying with JDK 9, don't. And the reason I say that is because JDK 9 will only have public updates until next month. When JDK 10 comes out, that will become the one to use. JDK 11 is termed a long-term support release, so I know a lot of people are thinking about waiting for that. And then my last slide is just, again, my marketing slide here, just to remind you that Azul do have a build of the OpenJDK that we make freely available. It's called Zulu Java. We build OpenJDK, we run the TCK on it, make sure it passes all the tests, and then we support multi-platforms. So we've got Windows, we've got Linux, we've got Mac. We have ARM support, we have Windows 32-bit support, we have PowerPC support, lots of different things. We also support older versions, so JDK 6, 7, 8, and 9. So if you're interested in that, have a look at zulu.org/download. And again, we are a commercial company, so we sell support around this. So with that, thank you very much.